Welcome all my dear students of TYBSc physics class. In previous lecture we studied about various parameters, important parameters of JFET, and we also studied some important application of JFET, and we also studied one of the important application of JFET as a shunt switch. Now here in this lecture we are going to study the FET as a series switch. So this is the figure A, illustrate JFET as a series switch, and figure B is equivalent circuit for JFET as a series switch. The JFET will either conduct or cut off depending upon this VGS. When VGS is 0, that is having high value, 0 is nothing but high value, this JFET conducts, and when this VGS is having negative value, minus value, that is this remains in cut off. What I say, when VGS is equal to 0, that is high volt, at that time this is conduct, and when VGS is having negative value, minus value, that is low value, then FET is in cut off condition or cut off state. Okay. See, remembering that current is always flowing. Suppose this is gate, this is source, and this is drain. Remembering that the controlled current in JFET is always flow from source to drain. We substitute source and drain connection of a FET like this. We substitute the source to drain connection of JFET for two ends of the switch like this, two ends of the switch. Here, when VGS is high, that is 0 volt, when VGS is high, that is 0 volt, JFET operates in ohmic region, and when VGS is low, the JFET will in pinch off, thus forces into cut off. For normal operation, that is AC signal, this is AC signal. For input signal, we have like input or serve as input for this circuit, and this is the AC signal serve as input for this equivalent circuit. For normal operation, the AC input signal voltage must be small. This AC input signal, this and this must be small, about 100 millivolt, so that it ensures that the JFET remains in ohmic region. When this value is high, then JFET does not remain in ohmic region. So in order to remain the JFET in ohmic region, this input signal must be of the order of 100 millivolt. Okay. When it is possible, when the signal reaches its peak value. Okay. Also, the drain resistor, the AC resistance, that is RD, this one and this one, RD must be very large as compared to the drain source resistance, that is RDS. What I say, in both the cases, RD must be very high as compared to RDS. RD is nothing but AC drain resistance, and this is nothing but source drain resistance. Why it is so? When this is the condition, when RD is very large as compared to RDS, it ensures hard saturation. And when VGS is high, now see the condition. When VGS is high, that is JFET operate in ohmic region, the JFET conducts. And since its resistance RDS is very small, V out is equal to V in. and switch is closed. switch is closed like this. When VGS is low, that is having negative value here, negative value, the JFET is cut off, JFET is cut off and it does not conduct. In this case, switch is open like this, switch is open like this, and here in this case when switch is open, V out is approximately equal to 0. Therefore, the JFET series switch, JFET series switch either transmit that AC signal or block the AC signal. Okay. Now we are going to see the important application, another important application of JFET as a multiplexer. What is multiplexer? Multiplexer, analog multiplexer, is a device which is having many inputs and it selects single output out of that many inputs. Okay, what I say, multiplexer, analog multiplexer. Next one is analog multiplexer. Multiplexer or an analog multiplexer is a circuit that is having many inputs and this circuit select or steers one of the input signal to the output, and this is shown in this figure. See here, suppose this is first JFET, which is having gate voltage V1. Okay, and here signal is given. This signal sinusoidal wave. Okay, now there is another JFET which is having gate voltage V2. Now consider one more JFET having gate voltage and here is the output. Resistance RD, AC drain resistance RD. So here triangular view, and here square view. This is analog multiplexer. See here how it works. I am again going to tell you that an analog multiplexer is a circuit that selects any one signal from the input side and gives to output, or in a simple words we can say that an analog multiplexer is a circuit that steers one of the input out of these three, one of the input to the output line. This is output line. Okay, in this circuit each JFET acts as a single pole single throw switch, single pole single throw switch. And when the control signals V1, V2 and V3, these are the control signals. When V1 or V2 or V3 is having 0 value, that is high value, at that time the corresponding JFET conducts. And when VGS, that is V1, V2 and V3 is having negative value, that is low value, at that time the JFET, corresponding JFET remains in cutoff region. Okay. By making any control voltage equal to 0 out of these three, by making any control voltage 0 equal to 0, one of the input can be transmitted to the output. For instance, when V1 is equal to 0, the signal obtained at output will be sinusoidal, because these two, when this is 0 and this is other than 0, that means this is conduct and sinusoidal waveform is transferred to output. When V2 is 0, that is high, and V1 and V3 is other than 0, that is low, at that time this is conduct and both of these in cutoff region, and triangular wave is transferred to output. And when V3 is 0, that is high, and V1 and V2 is low, that is having negative value, at that time this is conduct and this two remains cut off and square wave is transferred to output. Normally only one of the control signal is 0. Okay. Now we are going to see some advantages of FET over BJT. Sorry, advantages of FET or BJT. I am explain here some important advantages of FET over BJT, and these are nothing but first advantages. First advantage, FET has extremely high input impedance and low output impedance. This is the first advantage of FET over BJT. What I say? FET has extremely high input impedance and low output impedance. Second advantage of FET over BJT is that FET has a very high power gain as compared to BJT. Third one, FET has a smaller size and longer life and high efficiency as compared to transistor. FET is less noisy than BJT. This is the fourth advantage. Then FET has negative temperature coefficient of resistance at high current level and avoid the risk of thermal runaway. Whereas in transistor has positive temperature coefficient at resistance, BJT has positive temperature coefficient of resistance at high current level and it cannot avoid the risk of thermal runaway. There is a thermal runaway. Now next, that is advantage number 6. FET is much simpler to fabricate as IC and occupies as a less space on IC chip, whereas BJT is BJT is not simpler to fabricate as IC and BJT occupies more space on IC chip. Okay. Seventh advantages, FET has better thermal stability as compared to BJT, that is bipolar junction transistor. Then next advantage, that is advantage number 8, the frequency response of FET is very high, whereas frequency response of BJT is very low. Then advantage number 9, FET has high degree of isolation between input and output, whereas BJT has low degree of isolation between input and output. And last but not least, FET is a voltage control device where transistor is a current control device. So drain current can be easily controlled by the electric field in FET. Okay. And beside these advantages, there is a disadvantage, single disadvantage, and that is nothing but disadvantage of JFET. There is a single advantage, and that is nothing but main disadvantage of the JFET is the relatively low gain bandwidth, whereas transistor has high gain bandwidth product. Okay. I am again going to repeat the disadvantage. The main disadvantage of the JFET is the relatively low gain bandwidth product as compared to BJT. Now, we are going to compare, or we are going to study the comparison between JFET and BJT. JFET and BJT. First of all, FET, JFET, and here BJT. We are going to study between JFET and BJT, comparative study. See here, first JFET is voltage control device, whereas BJT is current control device. Second thing, field effect transfer. JFET is, or FET is unipolar device, that is current conduction is due to either electrons, free electrons, or conductive holes, whereas BJT is bipolar device, that is current is due to both free electrons as well as holes. Then third one, FET is, or JFET is unijunction device, whereas BJT is bijunction device. There are two junction, and here this JFET is having single junction and BJT is having two junction. Next one, this JFET has very high input impedance, very high input resistance, whereas BJT is having very low input resistance. Okay. Next one, FET has negative temperature coefficient of resistance at high current level and prevents from lead to thermal breakdown, whereas BJT has positive temperature coefficient of resistance at high current levels and prevents leads, does not prevent leads to thermal breakdown. There is always thermal breakdown. That's why this FET is having better or very good thermal stability as compared to BJT, or we can say that BJT has lower thermal stability, or thermal stability of BJT is very poor. Next one, FET has higher switching speed and cutoff frequency as compared to transistor, and transistor has lower switching speed and cutoff frequency. Then next one, FET does not suffer from minority carriers storage effect. FET does not suffer from minority carrier storage effect, whereas BJT suffers from minority carrier storage effect. And when we going to compare the noise, FET is less noisy and BJT is comparatively more noisy. Then JFET is immune to radiation, that is, it is free from radiation. There is no effect, or it is safe from radiation. In a single word we can say that JFET is immune to radiation, that is JFET is safe from radiation, whereas BJT is sensitive to radiation. Okay. Next one, FET has less voltage gain. FET has less voltage gain, and comparatively FET, the BJT has more voltage gain. And last one, FET is much simple to fabricate as an IC and occupies a less space on IC chip, whereas BJT is comparatively difficult to fabricate as an IC and occupies more space in IC chip. Okay. Now, I would like to tell you that N channel JFET is very popular and having wide application range as compared to P channel JFET. Why it is so? For that purpose, see here the difference between N channel JFET and P channel JFET. I told you that this N channel JFET is very popular as compared to P channel, and this is having wide range of application. So this N channel JFET is widely used and having more popularity as compared to JFET. Why it is so? To see here. The current conduction takes place due to electrons. Here current conduction in JFET, current conduction takes place due to electron, whereas P holes, the current conduction takes place due to holes. Okay. Now when we looking towards the switching speed and cutoff frequency, obviously N channel JFET having high switching speed and cutoff frequency is high, whereas switching speed and cutoff frequency of P channel is comparatively low with N channel. Next one, N channel, in case of N channel, its transconductance is very high. Transconductance, that is GM, is very high, whereas transconductance of P channel is very low. Now when we compare the noise of both, then it is less noisy. N channel JFET is less noisy, and comparatively P channel JFET is more noisy as compared to N channel. Okay. And last one, it is superior. N channel JFET is superior in circuit application, and comparatively to N channel it is less superior in circuit application. That's why N channel JFET is very popular. Okay. Now in next lecture we will study the MOSFET, that is second type of FET. Up to this point we study in details JFET along with its application. Now in next lecture we will study MOSFETs, types of MOSFETs, working principle of MOSFETs, and more than that. Till then we shall stop here. Have a good day. Thank you.